Hi, everyone. I'm Eshed from BU ECE. Thanks for Red Hat for inviting me here today and giving an opportunity to share with you some of our research in scalable AI systems. So we call this project the Co-ops project. Co-ops is an open source platform that is designed to enable anyone to participate in collaborative training of large AI models. Before I start, I want to thank an amazing team of collaborators at Red Hat, industry, and of course an amazing team at BU of students. Without them, none of this would have been possible. And introduce you to Evelyn. So this is Evelyn. She comes to her office one day and she starts pondering. So she thinks to herself, we have amazing computers in our pockets, powerful computers more than ever before. We have people in space. But somehow every year, over 1.3 million people die in traffic accidents around the world. And so she decides to investigate this problem further.
Whatever we can get off of the vehicle as unmodified.
And she finds out
NavLab 5 was a stock minivan, complete with laptop computer and multiple television cameras for front, side, and rear vision. Alvin was replaced by a more sophisticated neural net system, Ralph, which could handle lane change.
She finds out that 30 years ago, a car, 30 years is a lot of time in computer time. 30 years ago, there was a car that drove mostly autonomously, 98.2% of the time, from East Coast to the West Coast. And then fast forward to today.
Then another.
It was just insane. Like, they need to get better at seeing where each other are positionally and lining up. I mean, all of them are like facing sideways in the street, trying to navigate around each other, even though they're all part of the same network.
Matthew Seiler.
So we have these cars, many of them getting stuck at intersections, causing traffic accidents. This has been pretty slow. This development has been slow and riddled with challenges. These prototypical type vehicles that, maybe Tesla is a level 2 out of the 5 levels of autonomy still today. Waymo only operating in 2 cities, San Francisco and Austin. And other companies struggling. So Uber, Cruise recently halted their operations, Apple. So Evelyn decides to do something about it. So she looks online. She can't find a publicly available model for this task, but she can find some open source code that's pretty clean. And she wants to train a model. But she can't because data is very costly to collect in this space, often with sensors and curation. And most of it, because of that, is kept private and centralized, so concentrated in just a few key players that also have the most compute, like Tesla and Waymo. So she realizes that on her own, this might be difficult, but with the help of her friends, she might just have a chance. So for decades, we've observed this really slow and inefficient development in this space, and that's why we wanted to approach a more collaborative framework that can be used to rapidly collect tons of data distributed from all over the world, all the time, and share computation with the ultimate goal to develop an open source, transparent model that can be rapidly improved and iterated upon. So that's the goal of co-ops. And we've been working on building a scalable framework in a step-by-step approach for edge AI here. So tackling fundamental challenges such as learning from really diverse data like dashcam videos from the web, adapting to different geographical locations, learning from feedback about what's safe, what's unsafe, different traffic rules and social norms, and ultimately as the data is being streamed continuously and the world is changing, updating the model in a never-ending process where data is sorted, thrown out as needed, and retained in order to remember important experience. Much like how human drivers do when they start from novices and they turn into experts over a process of many years. So let's look at the model. Actually, the task is very simple. We want to go from the left side, which is observation image, to some decision, driving decision. And the problem is we, on the left side here, it's not just pixels and data. It's actually humans with different behaviors, different social norms, different locations. And so you really need an expressive model that captures this. So we designed a new type of model that can adapt its decisions across locations. And we evaluate this model over all of the publicly available data sets we have today, which is 11 cities, shown here, all over the world. Now you can train a model in a centralized manner by storing all the data in one place and training over it through many iterations. And you might get an error of 1.05 in meters compared to the how human drivers drove. And you can see that the distributed approaches, we call these federated approaches, are actually quite poor at this task. So the errors are high, but for our model, we actually find that we not only outperform all the federated baselines, but we also outperform this centralized baseline. So this means we're doing something right. We trained this model over very diverse data from the web, dashcam videos from all over the world, freely available data that's being uploaded to YouTube every day. And then we test it on this 11-city data set. So you can see how the model, by watching YouTube, learning to drive at night in a complex maneuver of overtaking a parked vehicle on the shoulder, driving in the rain with poor visibility, and even driving at night in Miami, so different locations. So this is a type of scalability we're thinking about here. And going all the way across the world to Pittsburgh and then to Singapore, which will be shown next, where people drive on the left side of the street. One model for everything. So I just want to mention that even though there's very diverse data here, humans, so there's diverse human data, diverse drivers and diverse videos that we use to train. Humans don't really learn in this manner, so they don't really just watch how people drive, but they actually learn from feedback, how to improve and why. And I still have these memories of my sister yelling at my dad to slow down, to drive slower, giving him feedback, and my dad yelling at my brother to avoid the potholes. So this is usually how we learn. We designed this feedback-based approach for training the model. And this is really powerful because anybody can give feedback to the model in this manner through language. So again, we have the same framework of going from an image to a decision shown on the right in future goals. And in green might be what the human would do, but in gray might be what the model predicts. And so we can then give feedback to the model where we tell it, you're going to collide with something in 3 seconds, so this is why it's a bad decision. And when we give it that type of feedback, it's able to learn much more effectively. So we update it with this feedback. This approach outperforms all LiDAR-based approaches just using RGB. So the baseline model, we test it extensively in simulation. The baseline model tries to make a lane change, but collides with this police car. Not a good idea. And our proposed model, we're able to say this is unsafe and successfully completes this complex maneuver. So no collision and driving okay in this intersection. So we validate these models in simulation as well. Here is another complex scenarios with puddles. So the baseline model stops for the cyclist, but doesn't take enough turn. So gets stuck. And then collides with the pole. Whereas our model is able to seamlessly turn with enough radius to safely do this maneuver, while avoiding obstacles and the cyclist. So all these methods that I've shown you until now were actually trained on about 10 hours of video data where we test things. But there's thousands of petabytes of data being uploaded to the web every single day. So we design a system that can watch one video at a time, but sift through it. Highly efficient system. It never sees a video again. So it goes video by video, and removes useless information, irrelevant information, but also keeps in a memory buffer the most important experience so it doesn't forget it. And it's a continual, never-ending learning process. And for this framework, we can actually train, and it's still training in our lab right now. So we said to just keep letting it train over millions and millions of images in unprecedented scale. You can see some of the automatically selected buffer samples here, highly diverse. You have different weathers, urban versus rural conditions, and you can see that we outperform all other approaches in continual learning for this task. So we are the red curve, and you can see how the error keeps going down over many, many images. This is interesting. So these are some samples that the model selected to remove. So you can see these are automatically removed, and these are irrelevant frames with ambiguous cases where maybe there's a frame transition or anything like that. So we've been integrating this frameworks into NERC of both collaborative training and a collaborative community source repository for data for training and evaluation of these models. So this is running on NERC. Okay, great. I think I went kind of fast. So we discussed a path towards addressing challenges in closed source development of edge and AI systems. So there's still some key issues. One of them that I'm interested in is these agents that are participating in this distributed network. How do we incentivize them? So how do we make sure the system is self-sustaining and not something that just disappears? That is a really tough problem that I think would be interesting to tackle next. So here's my email. If there's any questions or any ideas on some of these problems, feel free to reach out. And I'll be happy to answer any questions.
Super cool. Thanks so much for that talk. So you know the classic problem that we all seem to be at the mercy of right now when we talk about open learning and open data, the question of an adversary wanting to corrupt our information source, right? Now, there are various things that one could imagine denial of service inspired like attacks on this versus, you know, at the YouTube level versus at creating enough false frames, things like that. Do you have any thoughts about that?
Yeah, thank you for the great question. So if adversarial data is really hindering to the model, actually, so in all these data collection efforts, they try to curate it as much as possible. Actually, even diverse data can hurt the model performance. So it's almost like a task where humans trying to remove data that might be too much for the model. But adversarial cases are difficult, yes. So one case could be in training time, where there is a data poisoning attack. And especially in this case, you would want to detect it and remove it. So there's ways to do this, but obviously this is a difficult problem. So one way would be to validate the model performance, and if they go down, if the model performance goes down, that maybe this data should be thrown away. Actually, there's a related problem to what you're saying, which is you know, kind of like nodes that don't really contribute, and maybe uploading junk data. So you want to remove those. So what I like about this framework, if in theory, you could use the model uncertainty to filter these samples, which is what we're doing here. But we haven't tested this with intentional agents that are trying to adversarial attack. But this is a bit like that, because somebody edited these videos and there's a transition. The model is confused by that and removes it. Yeah. So, but often adversarial samples are not even may not even be perceptual to humans. So it's a really tough problem. But then in that case, this actually even motivates something like this even more, because then you would want some automatic process to remove these. In test time, adversaries are a very difficult problem. Yes, and I think that one way to solve it is through scalability. So imagine a proportion of data where, as long as most of the nodes are, so it's kind of like a consensus thing, but as long as most of the nodes are uploading data, and actually the larger the network is, the less the impact of these adversaries, because maybe they are pretending that there's a traffic accident when there's not, but other people are also viewing it at the same time, and then you can say, okay, this is unlikely. But this is a really interesting point, so I think we should look into that. Does that answer your question, or?
First off, I also want to be clear, like, I think this stage of work is phenomenal, right? Because we have to know that these things even make sense. But actually it was that latter point that I was very curious about. Mm-hmm. Does this become an arms race of computational capacity? And are we back down to like all the other kind of money kind of stuff, where it's like, look, everybody who would need to be able to corrupt this would have to operate at such a scale, it makes it impossible. And does that always place, quote unquote, us open source good guys, for whatever label that means, mm-hmm. in jeopardy of the big players, because they're the ones actually who have the computational capacity to launch serious attacks on the open source models?
That is, yeah, so another really great question, because that's very likely to happen, especially at the early stages. So we are, you know, kind of for these type of systems, AI, it's kind of like the early days of operating systems. You don't really have a collaborative standard, and there's a lot of resistance, actually, so especially from the big players. Yes, so actually, I went to a conference, one of the biggest AI conferences, and I went booth by booth, and I asked them, and they described this as some kind of a utopian view, but it is inevitable. It must be inevitable if we do it right. The world is constantly changing. It is. So I think the reason this has been so slow is because it's beyond any single player. So whenever they are ready to join us, they're welcome to. And there's good nearest neighbors to this approach. Besides operating systems like Linux, there's OpenStreetMaps, which was actually, are you familiar with that? So OpenStreetMaps is an effort that was mostly crowdsource GPS data that was uploaded for many years and often ignored by Google. And then what happened is Google raised their price. And so others were looking for a cheaper solution, and suddenly Apple started contributing to this open source effort. But that is exactly what I'm wondering about, right? So there must be, oh, did I disconnect something? There must be some way to incentivize this so it becomes self-sustaining and explodes. And I think that is a very tough thing to do. But I think the simpler the framework, the better, more people can use it. Right, you ask a good question about the money side. Yeah, that is a difficult problem. There's a lot of money in this space. Whoever solves the problem first, right, so this leads to this race, and they don't want to share their data because of that, right? So, but then there's, you know, so if, how can you develop efficiently? It's so slow, right? If it's just one company doing all the, so Tesla has been the main leader, the main horse in the race here. And so I guess the quick answer is I don't know.
Elevate something that we as public academics can do here beyond, because I think what you've got, you know, when we talk about speaking to legislators and getting involved in helping understand these technologies and the impacts they're going to have, to be honest, I don't want it to be companies who are the sole advisors to legislators and government bodies, but I think when you have such concrete work like this, that they can actually start to see what we're talking about and argue whether, look, maybe all is not rosy on the other side of the global AI fence. And these are the kind of things why public funding, public legislation, all of it can get engaged.
I think it's okay, but yes. So regulators, I think. So when I talk to people in DOT, I think there is lots of interest, but there is. It's so disorganized right now that right. But I think that would it would have to come from something like that. But I really wish it was emergent, and in hindsight, it might be something that was clear. But today, right, it's so early. Actually, your question, leads to a lot of follow-up interesting questions. Like, there's especially in the adversaries areas. So we see, so people are in some areas are very resistant to this technology, and at the same time, you know, actually, if you think about the development of this technology today, it's mostly done in like rich sub-areas of cities. So people may not be able to benefit from it either, right? So if you just leave it to kind of pure company-driven interest, especially, so that would just lead to what happens today. We have one monopoly and they're doing something like that, right? But yeah, the open source route is always tougher, more difficult, but if we can pull it off, I mean, then AI will empower people in a way that, right, so that's the idea. So I think an open source model for something like this I think that means everybody understands it better, right? So maybe it works 99% of the time, but in some cases it doesn't work, and everybody knows that, and you can inform the user. So there's also the legal perspective, which is totally I would not be the best person to comment on that, but I don't know if anybody really knows yet. So it's thanks for your questions.
Hey, Eshed. That was a great talk, really interesting project. I was thinking about other things besides videos that can be uploaded and shared and open sourced. And you didn't talk too much about how you keep track of where things came from. I mean, obviously you do to some extent, but how do you handle that problem? I'm thinking of an example called PerfSonar, where people who ran networks uploaded data about the latency and the throughput on their networks from different points all around. And the data got thrown away, so you knew perhaps the results of tests, but you no longer had the source data if you made conclusions. So it's similar problems in lots of different domains.
That's a great question. So how do you keep track of where the model came from, where
Well,
the data came from?
In your case, where the videos, so you said it's watching, you know, all the videos all the time, everywhere, and obviously not saving them all. So do you just say, no, I can't keep track of it, and I'll just go with other approaches for keeping track of what my model's doing, or do you try to keep track of what it looked at?
So actually, GPS data often is part of this video. So if somebody uploading GPS data is possible, you know, especially if it's something like a smartphone. This is usually GPS data. But then obviously this leads to a privacy issue where suddenly everybody's activities are visible all the time on this network. So in this geo-aware federated learning, you do not have to share your location. It's only kept locally. And it's something that you apply to the model once you download it, and then locally it applies it to some local location. But, and it only needs to be defined over regions in this. So we did cities in this specific thing. So it's not like exactly where you are. And it learns, you know, how to drive in different cities, you know, Miami versus Pittsburgh left. But anything that any metadata that we have on top of the videos would be super helpful. So there could be some ways to even encourage people to upload that, especially if there's something like OpenStreetMap where they are participating in uploading GPS data. And they then add additional things to that, and we integrate with that, then that would be one potential way to go about it. Does that answer your question,
Yeah,
Heidi? Or?
no, I was just wondering how you managed it, and so yeah, basically you have to encourage people to upload the extra data that you want to see for what you're doing with the research.
Right. The metadata helps a lot because so the current models, so most studies only evaluate over 2 cities when we do research. So they don't really think about this geographical distributed learning. But if we have that information, it will help the model a lot, yes, because the decision might be totally different. And if you're in, you know, some other city on the other side of the world, or in Europe, then you must adapt your driving decisions. So I think, so actually ideally we would have ways where we either say, okay, this is private, you can keep it local, you don't have to share this information, or you can share it and maybe share more of the raw data, and that actually is the best for the model. So that's always the best in the end.
Thanks.
Thanks for the question. Sure.
Hi. I really enjoyed the talk. I was thinking when you talked about keeping this going and open source, perhaps one venue that could be pursued to incentivize the private sector is to provide free dash cams to, say, Uber, because with Uber you have all that metadata about the quality of the driver and the routes and all of those things, and if you give free dash cams, then you can collect the data if they agree to that. But then also, I noticed in one of the slides, your car, when there was a cyclist that went in front of the car, it didn't decelerate necessarily, and so doesn't the quality of your source data matter a lot, and not just having, you know, people who don't hit pedestrians, but people who make pedestrians feel comfortable when they're driving?
Yes. Actually, I hope that's a really great question. Thank you so much. So again, this question has many questions within it.
Yeah, sorry.
But I'll try to answer it quickly because I think we have like 1 minute. And then if there's any other questions, let me know afterwards. So I'm hoping that this feedback-based approach, maybe you can specify ways in which you want it to drive, so you can adapt the model through that to different users. But right now, it just makes one prediction. So it's not predicting a diverse. So this mechanism of adaptation over like locations is very naive, I still believe. So because even within a location, you can have different preferences and maybe different modes of driving. So and I think that was part of your question. So I think that is yeah, that is tough. So you would ideally want to probably generalize this to include different preferences of how people are driving. So we haven't looked into that yet, but it's almost like the next question. So I really like that question. There's another aspect of this open source tools where students can now also tinker with the model and build on that. So I think tools like that are super important for education as well, that I didn't really mention. And both for users and for students and for any user pretty much. So
Thank you.
great, thanks for the question. Is there anybody else? Can I mention also diverse predictions is very important for safety. So if you you want to model like multiple outcomes in the world and then based on that make a decision. So maybe a kid can run into the street at any given time even though you don't observe anything. So that is another, that's why you need a lot of data so you can capture these cases. So maybe then the current models they can handle such things. So, thank you so much.